Are you faced with HOA restrictions or an XYL who doesn't want any visible antennas? Well, if so, then this video is for you, with some tips on attic options you may have, some suggestions and ideas, and a look at the design and installation of one of my attic antennas. As you can see from these logs, this attic antenna can provide many worldwide contacts and lots of satisfaction. I've been a licensed ham for over 60 years, and I've tried dozens of different antenna types over those years, and I've learned some things that are worth sharing, especially if you are new to the hobby or don't have an electrical engineering degree. When I moved from my hilltop home with the 60-foot self-supporting tower with tribanders, dipoles, and verticals to an HOA antenna-restricted new home, I had to think about antennas differently. I actually thought that an attic antenna may not work well enough to justify the effort of installation. Boy, was I wrong. And with a little work, you too can get satisfactory results, and maybe this video will help you a bit. All ham antenna systems involve compromises of one sort or another in physical size, resonance, bandwidth, height, directionality, number of usable bands, power handling capability, matching, and many other parameters. The important thing to remember as you consider all the possibilities is that every properly matched antenna, even severely compromised antennas such as a 20-meter car mobile antenna, will radiate energy and make contacts. The goal is simply to make the best of what we have to work with, and that's what this video is about. So let's begin with my attic. It has a steep gable which allows about 9 feet of vertical height above the base of the antenna. The roof is all wood construction with shingles, and there is no metal or foil below the shingles. The insulation is blown-in cellulose between the ceiling joists. After a lot of trial and error testing with several types of antennas, the most optimal approach for a 40 through 10 meter antenna for my house was a modified vertical with an extensive radial system. You can give it a lot of different names, but because the vertical component has the most current and does much of the radiating, it's more like a vertical than anything else. So we'll call it the attic tilted vertical system. The materials for this antenna all came from what was saved from my old QTH antennas. The bottom 8-foot section is a part of the old tri-band beam driven element, including the 10-meter trap. Above that section is a 3-wire extension which follows the slope angle of the roof until the peak and then continues horizontally just under the main roof rafters. The total physical length of the antenna is about 22 feet, but the electrical length is a bit longer, approximately 23.5 feet, due to the 10-meter trap. The antenna is non-resident on all bands but the 10-meter band. I'll have more about the decisions about some of those parameters later. The radial system in the counterpoise consists of 36 equally spaced radials made from individual wires left over from the rotor cable from the old system. 8 of the radials are 33 feet long, or about a quarter wavelength on 40 meters, and the remainder are about 16 feet long, or a quarter wave on 20 meters. All of the radials lay on top of the ceiling rafters in the insulation and above the other wires and fixtures in the attic. In addition, a piece of thin copper mesh about 8 feet square is part of the counterpoise system, and the antenna is located in the center of that 8-foot square. A heating air conditioning metal air duct about 15 feet from the base of the antenna is also connected to the counterpoise. The system is fed with about 75 feet of RG8X coax with RF chokes at each end. Inserted between the end of the coax and the antenna is an MFJ, an automatic antenna tuner. My rig is an ICOM IC7300, and I usually run about 95 watts at full power. I don't have any RF interference problems in the house at this power level, and the noise levels are acceptable. So that's the current installation, and I believe I'm getting as much efficiency as possible out of that system. The MFJ autotuner does an excellent job of matching the complex impedances and allows operation on all bands from 40 meters down to 10 meters. The radiation efficiency of the system is improved on several of the higher bands as the electrical length exceeds a quarter wavelength, creating a higher base radiation impedance and an even lower radiation angle. I've made lots of contacts on 40 meters with this antenna, but the electrical length is a bit short, and I have an attic 40-meter resonant dipole that generally works better, especially with near vertical incident skywave type contacts. While my system is operating at a high level of efficiency, its low height and indoor location simply can't produce results equal to a full-size dipolar beam at one or more wavelengths in height. However, I do get excellent signal reports and comfortable QSOs. I just don't expect to be the winning signal in pileups or during poor propagation conditions. Attic antennas do have one fantastic advantage, though. They're out of the wind, they're out of the weather, and there's no ultraviolet radiation to deteriorate things. So once you're done and all fixed up, you can expect everything to stay exactly as you installed it. Dry wood is an excellent insulator at low frequencies and power, so mounting the antenna is a snap, since there are plenty of rafters and beams to attach to, allowing bending as needed for extra length or drooping ends or for other reasons associated with your attic. Now let's talk about your attic installation with some tips and suggestions. Take a look at your attic before you start and estimate some antenna lengths that might fit. The physical parameters will determine what options you may have and what bands are feasible. For example, if you have a low-pitched roof with only 3 or 4 vertical feet of spacing at the center, you may want to consider a resonant dipole inside or even a stealth dipole wire along the top of the shingles outside or vented ridge. There are several good videos about these types of installations, and I believe you would get satisfactory results. Use an automatic antenna tuner at the feed point if you want multiband operation from the dipole, and consider the possibility of off-center feeding for better matching on some of the bands. If you do have some vertical height in your attic, say 7 feet or more, the inverted L could be a good choice for a 30 through 10 meter antenna or even 40 through 10 meter antenna. The counterpoise radial system can really improve the efficiency, particularly if your house is a single story and or the earth-ground conductivity in your area is low. My attic tilted vertical system evolved over several months of testing. I tried doublets, dipoles, and single-band verticals, and finally settled on this system as the best one for me. Along the way, I made several decisions. For example, the 10-meter section of the antenna with the trap was included because the radiation angles on the higher frequencies get very complex and very unpredictable with a longer antenna. The 10-meter trap made the antenna appear to be resonant as a quarter-wave vertical on 10 meters with very uniform omnidirectional radiation. This has been proven with actual operations. The trap also increased the electrical length on the vertical section for all the lower frequencies as well. It was just an idea that I wanted to try, and I'm very satisfied with the results. Another idea was to use a triple wire extension above the 10-meter aluminum tubing section. I needed the wire for flexibility to follow the slope of the roof, and bending aluminum tubing was more than I wanted to do. The wires are attached to the end of the tubing with a hose clamp. I used some 450 ohm 14 gauge open wire feeder line that I had made for another project and added a third wire in the middle. Theory would suggest that adding to the electrical diameter of the radiating conductor might increase the bandwidth of the system and increase the aperture for receiving. These are all great theories, but who knows if those theories would hold up in an actual installation such as mine. The base of the antenna is about 12 feet above the very low conductivity ground that I have in this area, and the counterpoise system is a substitute for real ground, adding some efficiency. The radial wires are small gauge and insulated. The small diameter and insulation will have little effect on the efficiency, but the number of radials and their length have a large effect on efficiency, although that effect does diminish as the number of radials increases. Also, having the base of the antenna well above ground should help the efficiency too. Using an automatic antenna tuner at the base eliminates mismatch losses as SWR in the transmission line, and also allows a lot of leeway in determining the length of the antenna since resonance is not important. The tuner makes the whole process easier and allows a wide variety of antenna lengths and mounting locations in your attic. Remember, with antennas, everything affects everything, and trying to obtain resonance will always be a cut and try process, and it can be very frustrating, especially with a multi-band resonant antenna such as a trap vertical or fan dipole. One last bit of advice: as you think about which antenna or antennas you may want to use, take into consideration the ease of moving around in your attic. Some are pretty tight. If so, pre-planning can save trips, and you might even think about getting help from a younger ham or even a grandson if the physical work is a little outside of what you can do. Using an antenna tuner will eliminate having to prune the antenna to resonance and also allow multiband operation. You will have to provide power for the tuner, but that can be done through the coax. Also, you may want to run a control cable for the tuner so that it can be controlled by your transceiver. So my advice: don't give up on ham radio if you move to an HOA restricted location. Just think about putting it in your attic. It isn't optimum, but it will work with just a bit of effort. And I'm sure that with time and patience, you can work anywhere in the world that you want. 73s, and good luck with your project, and hope to hear you on the air one day.